NATO nations decided that the alliance will acquire the capability to defend European territory and populations against missile attack.
This animation illustrates how NATO's ballistic missile defense capability is designed to work in a hypothetical scenario. NATO conducts thorough planning to make the best use of all weapon systems and sensors under its command. First, the threat posed by hostile missiles is determined based on intelligence estimates of threat capabilities. Next, national critical assets and areas are identified, and a detailed defense planning process begins. Finally, ballistic missile defense assets are assigned specific roles. Early warning is provided by satellites to sea and land-based assets deployed as part of the defense design. When a ballistic missile is launched towards the alliance, the NATO commander is alerted as its heat signature is detected by an infrared satellite. That information is then transmitted to a ground station for analysis. Planning and analysis are led by NATO's Headquarters Allied Air Command in Ramstein, Germany. When the threat is confirmed, the information is sent to all appropriate command centers, sensors, and weapon systems. As the hostile missile continues its ascent, the engine concludes its burn. At that point, the infrared satellite can no longer detect it. Long-range sensors, such as the United States land-based ANTPY-2 and the Netherlands sea-based SMART-L radar, then detect and track the missile. They forward the information to the command and control system so that intercept solutions can be calculated. The NATO tracking capability also includes the U.S. Navy Aegis Combat System, featuring the AN-SPY-1 radar, which is capable of tracking more than 100 objects. Together, these sensors create a robust detection and tracking capability. As tracking continues, greater accuracy is achieved. The sensors follow the missile as long as possible and share updated information with all other systems. A key feature of NATO's ballistic missile defense system is an upper layer intercept capability aimed at destroying missiles outside the atmosphere. This is provided in part by the Aegis ships. In the future, additional systems like the Terminal High Altitude Air Defense System, or THAAD, could also provide additional capability. In our hypothetical scenario, one of the threat missiles is engaged and destroyed in space. Threatening missiles that do re-enter the atmosphere become the responsibility of lower-layer elements, such as the Patriot system used by Germany, the Netherlands, and the United States, and the SAMP/T system used by France and Italy. All sensors continue to track threatening missiles. As the threat comes into range, lower-layer shooters engage and destroy any remaining hostile missiles.